Hey, do you want to learn how to code 5 games such as this, and that using Java and the LibGDX framework? My name is mpyanev and I've been software developer and engineer for many years. I've been working with all kinds of programming languages, mostly to develop applications for the game development and the aerospace industry. So LibGDX is a library that considerably simplifies the game development in Java and allows you to run your game on any device, such as Android, Windows, iOS, even on your browser. We will start by covering the very basics of Java and LibGDX, so even if you're a complete beginner, don't worry, you will be able to start from scratch. So after every code writing lecture, we will have a deep dive lecture, where we will discuss every tiny bit and component of the code that you just created, which means that you will never be lost or alone in your learning journey. So every next game will increase in complexity, so you will be able to build your game development skills progressively. We will start by creating the Hello World game, where I will simply introduce you to the LibGDX main functions, and I will basically show you how to display objects in your gameplay. Then we'll move on to the whole game, where the player will be able to win a prize by choosing one of 3 doors. And here you will learn how you can randomize the object behind the door and how to set up the whole game environment and the gameplay. The Hit Them All game will teach you how to develop multiple objects just by using a single source, how to add score detection mechanism and even sound once you hit them all. Then you will create the amazing Catch the Ball game, and this game will be a dramatic boost of your game development skills. You will practice the creation of the menu screen, recording the top score, playing background music and many more. So this course will end by creating the Get the Cheese game, where you will learn how to animate your game character, extend the game map once reaching the border, and also design the text that is displayed in your gameplay. I'm uploading completely free programming courses every week, so make sure you hit the subscribe button to get more coding skills. But why learning LibGDX? What is so special about this product that you need to know it? Well, I already have a course called Java Games Development, and there we're not actually using this library, but we're simply using the built-in libraries to develop games in Java. However, here we're using specific library called LibGDX, and this framework allows you to run the Java games not only on your computer, but also to export them on macOS, Android, and HTML. And this is not everything. Actually, this course is not made for the reason to show you how to export the LibGDX files in different devices. This course is specifically made for you to see how easy you can develop a professionally looking game with LibGDX, which is, in my opinion, way easier comparing to using simple Java. So after you complete this course, you will be able to develop games by yourself. You will be able to be creative and create your own games of your desire. So here you learn to make 5 games, and with this you learn plenty of functionalities and techniques to develop your own games, which is very important for a beginner game developer. You can find the complete 11-hour course in the link in the description. Hi everyone, today we're going to install Java for Windows. So let's go to the command prompt now. And here we are in the command prompt, and the first thing you want to do is to check if you have any available version on Java in your computer. So we'll do this by writing java-version, and as we can see, we don't have any version of Java in our computer. So let's change this. Write JDK in Google, and from the results go to the first one, Java SE Development 8. It's important to go into Java 8, and after that let's search down for the Windows version that is for 64 bits, as I'm using Windows 10. So here just accept the cookies. Okay, so we accepted them, and after that let's scroll down a little bit, and after that, once we find what we need, which is the Windows version, simply we need to click to download it. So here is the Windows version for 64 bits, and I will select this field here, and then I will download it. Just bear in mind that it could ask you for registration, so just register for the website and then download the version of Java. So here I will press the downloaded file, and here we have a few options, of which I'm going to select the accept one. So let's select this here, and after we do this we can start the simple installation of Java. Just press next everywhere, and finally the Java will start installing on your computer. So let's wait a bit, and after the installation is completed, press next. Then you will get a little bit more of installing software. So let's wait a little bit, and after everything is installed, just press the button here, close. That's it, and we're ready. Let's check if the Java is installed in our computer. So I will close the terminal, I will close the command prompt now, and after that I will just run it again, so we have a fresh start. And here write the same java dash version, and let's wait a bit. And now, as you can see, we have the Java installed in our computer. You're getting the version of Java, which is good. This means the install was successful. And let's check something else. I'll write java c or jvac dash version, so we don't have the jvac installed as well, and this is because we need to set the environmental variable, and I will show you how to do this. So go to program files in your Java installation, and here you have two folders. One of them is to run Java on your computer, the other one is to access Java from the command line. And here I will just select this folder, and then let's check here in the folder if we have the jvac. So in a folder that we have jvac, just copy the path to this folder. So just copy it, and after that go to my computer, okay, this PC, and then go to the properties. So once you go to properties, check the advanced properties, select the environmental variables, and we will add a new environmental variable here. Okay, it is actually very simple. So here are the environmental variables that our computer is using. In order to add Java to our path, we need to do the following. Select new here, as you can see. So right here the name of the variable, we can call it just path, and then just paste the copied address by Control V. Okay, and we're ready. So press OK everywhere, and now the jvac is installed, and we will check that by first closing the command prompt and opening it again. So open it here, and after that write jvac vac, that's it, dash version. And as you can see, now we have the jvac installed. So let's move on in installing Eclipse in our computer. So in Eclipse dash downloads, it automatically recognizes the version you need for your computer. So just select here download Eclipse. So as it recognizes that my version is Windows 10, it will immediately prompt me to this. So now I can install the version for the Windows. Just select here download, and now it will start downloading. Let's speed up the video a little bit so we're not waiting too much here. And now it's downloaded. Just select the X file and now press run. That's it. And then you're getting into the Eclipse installer. So what would you like to do is to install Eclipse for Java developers, and then simply press install. It will take a few minutes. So first accept the agreement, and then it might take you about 5 minutes to install this. Now press launch after it is installed, and here we are in the Eclipse IDE. Press next, and then we're entering now Eclipse, and you will see the welcome window, but you need to close it here. So once you get this window, just close it, and then you will be able to open a project in Eclipse and start building your project. So this is what we're going to do. Let's close the window here, and then you can select create a new project. And once you do this, you will be able to create your first Eclipse project, and let's test if everything works. So let's write the name of the project, and after we're done with this, after you wrote the name, you can check actually the configuration. So here in this folder, these are where the files are stored. Okay, you don't need to do anything about this here, I'm just showing you so you know. And then once you check that this folder is there, press next, and here we can build our project by pressing finish. Okay, select this button here, and that's it. So our project is ready, and let's create a class here. So here we have our class, and okay, so inside this project, let's create a new class. Okay, and here press public static void main option and choose the name for your class. Okay, so I will call the class hello world, and I will just print hello world here so we can check that everything is working correctly. So here in the main class, we are going to write system.out.println for print line, and in the brackets just simply write hello world. And once you do this, go here to the execute button and press OK. So now you can see that hello world is printed on our screen, which means Java is installed correctly. Thank you very much for watching. Hi everyone, today we are going to install some plugins into the Eclipse so we can run our LibGDX application. So let's go to help here, and then I will select install new software. So press add here, and let's write as a name of our add repository Android tools for Eclipse. That's it. And here I will place this URL. Okay, so just write it down here and then select add. So once you select add, you're prompted to this window here, and just select all the tools. So you have all the tools that are Android based, that you can use them on Eclipse. Then press next. It is very simple, and now the software will start installing in your computer. Press next here as well, accept the agreement and press finish. And now it starts installing. You can see this in the bottom right corner. Okay, while we're on the half of our installation, you might get this type of warnings here, but don't worry about them. Just press install anyway, so the installation continues. If you get more than one, just keep pressing install anyway, and the installation will not have any problems loading on your Eclipse environment. Once the installation is complete, please restart Eclipse so we can have a fresh start ready for our new installation. Then what you would like to do is just to install all the SDKs. Okay, so keep this option, install the latest available version, Android APIs. Press next here. I would select here no, because I don't want to send my statistics to Google, but if you would like to, keep this to yes, and press finish. So now you start to run the Android SDK manager. Here just accept the license and press install. And here some installation has started. Now after this is done, you will get the message the Android SDK requires new build tools component to be installed. Just press open SDK manager and you will be prompted to the SDK manager here. So now you will need to install some of the most important tools of the SDK. So these are going to be the API 29 for Android R, for Android 10 as well. And just keep the default settings. and select install 18 packages. Accept the license, then select Android SDK license, press here accept license as well, and finally press install. So now this installation would take quite a lot of time, so please be patient and I will see you once everything is installed. Okay, as you can see, all of our packages for Android SDK are installed in our computer. So the next thing we will need to do is to perform one next step, which is going to the help bar here in Eclipse, which has just restarted, and then go to the Eclipse marketplace. Simply write in the search GWT and then press the search button. Here we go. Okay, so you can see here the first result, which is GWT Eclipse plugin version 3. So just press install here and the plugin will start installing to your computer. Press the confirm button, then accept the agreement by selecting this button here and press finish. So as you can see in the bottom right corner, the installation has started, and once the installation is complete, you get an offer to restart your Eclipse, which you are going to take, and have the fresh start for the next installation. Here press install anyway, and here press the restart now button, so the Eclipse will restart. Then here press the help button, and again go to the Eclipse marketplace and we will download a tool called Gridle. So simply write here Gridle. So write here Gridle and press the search button. So we'll find the Gridle applications for our Eclipse IDE and select this option, Gridle for Eclipse 017. Press install here, and now Gridle will start installing into your Eclipse machine. Press confirm here and then accept the agreement and press finish. Now simply write in Google LibGDX, which will prompt you to the web page of the LibGDX. So select the first result and then select download. So here you can download the app for the LibGDX. So now we started downloading, and it will usually be installed in your download folder. So I will keep it, and now it's completed. So let's select this file and see what we're going. And here is a start screen for the LibGDX, and you need to do some simple things in order to start your new LibGDX project, and we'll actually test it here so you're sure that everything works properly. So as a project, let's write tutorial 1, then the package name, I will call it com Martin Y, then the class name will be game first. Okay, and here the first thing you need to do is to select the folder where you want your game to be saved. So it usually doesn't matter, but I will save it in the Eclipse workspace, okay, where all my projects are, but you can save it anywhere you want. That's completely fine. So press open here. And the next thing you need to do is to select the location of your Android SDK. So here press browse. So here usually in your names folder you can find the Android SDKs. So this is the folder of Android SDK. Press open and that's it. Now you have your folder of the SDK selected, and you also have the location where your project will be saved. That's it. Okay, I will remove these two types of projects, so we will only have the Android and the desktop version of our game OS selected. So that's it, we are ready. Let's press generate and see what's gonna happen. Okay, let's try to change the destination here. So I will select here my name, then Eclipse, and then here I will create actually a new folder. So always do this, create a new folder inside the directory you want to write, otherwise it could delete everything in there. So what I will do here is I will write slash game first, and I will press open. That's it. And let's select generate now. So as you see, we don't have any errors now, and our game will be simply created after a certain period of time. So I will see you when the installation of the game is completed. Okay, after our project is completed and it's ready, then what you need to do is to import it in the Eclipse. So here you can see on the project tab I have quite a few projects actually. If you just installed Eclipse, you have no projects there. So what you simply need to do is to select import. Okay, so here you will select import and then keep this on existing projects into workspace. Here press next, and what you need to do here is just to add the folder of the project you just created with the libgdx. So as you remember, this project was installed in the folder that had my name in the user folder. So here is the folder, just select it, and inside it you'll be able to find your projects. Let's look for it. So it was called game first. So let's look for game first. There we go. So this is your project, and just select here, select folder. And after you went into the folder of our game, you will get these 3 projects available for you. So I selected here this field so you can see all the projects, and just tick all of them and press finish. Okay, so what you will see here is the first thing you will see the project first game or game first, and after that you will see all the other projects here. Okay, so just select the one for the desktop. Here we go, and here we will display all the assets needed to see your application on Windows screen. Then select the src folder, and here in the package run this file. Run, and then as Java application, and let's see what is going to happen now. So you can see now you are getting your first test game here, and if you see this picture in front of you, this means that the libgdx is working and you can proceed. And today, after we had already the introduction to Java, it is time to talk a little bit about GDX, what it is and how we can basically use it. So the subject of the lecture today is how to create a libgdx project and import it in Eclipse. So you already have Eclipse setup and you already downloaded the libgdx file. So let's start now. I will select the GDX setup jar file, and then the window of the libgdx should appear in front of you. So this is the libgdx window, and here we have a few things. First one is the name of your file. Okay, this is going to be the folder, the name of the folder of your file, then the main package name, then you will define the main class. Here in the destination, this is going to be where your project is basically going to be located. Okay, so in this folder, all the files from your project are going to be saved. Then you need to have here the folder, and I showed you already how to find the Android SDKs and have the folder of the Android SDK. Then you have this tab here in which you can choose the platforms you want your game to work on. And since here we are going to basically test our games on desktop, I will always keep this desktop place selected. And the rest of the ticks, sometimes I'm gonna leave them, sometimes I'm going to remove them. It depends on the project. Then you have the extensions, and in the extensions, these are basically different libraries that you can choose whether you want to add or not inside your project. It is very simple. So if you are unsure, better select all of them so you know that you have all the extensions integrated inside your project. So let's create a simple project and I will show you how it's done. So the first project will be called intro project. Okay, then the package I will call Martin Y, and feel free to use your name here. com dot, and then you can put your name or initials. Then the class name will be intro project. Please note here that sometimes you need to put for the name of the project, let's say 1_ and then the project name, but in the class name it is not a good practice to do this because it might not get accepted from Eclipse. And actually this is how I'm going to do it: 1_ intro project, and then the class name will be intro project. Then you need to define a destination, so go here and then choose your folder where you would like your project to be. In my case, I would like my project to be in the introduction folder that I created earlier on, but here I'm going to write slash and then write the name of the folder that I want to create and place my project in. So see, if you leave everything like this, then the raw files of your project are going to be installed in the introduction folder, which is not a good practice. So here I also write 1_ intro project, okay, and I will press open, and that's it. You can see that we didn't have this folder intro project in the introduction folder, but now once we create a project, this folder will be automatically created. I will just mention once again how you can basically find your Android SDKs. So they're usually in your computer in your folder with your name, okay, so this is users, then the folder that is with your name, this is how you registered your computer, and here usually you find the Android SDKs that you installed in the previous lectures. So I'll press here open, and here we have the SDKs, and then I will this time leave Android and desktop ticks applied, okay, and from the extensions, as I said, I usually leave box2D only, but if in the future you create custom projects, I advise you to tick all the extensions. Then simply press generate and your project starts generating. It's important to know that in case there is some error or some message, the program will notify you, so you will know that and you will be able to change this. And that's it, your project now has been created. So you can see this message here, and also you can see that the generate button is again enabled. So you are ready, you created your project. Now I will close this and I will go in the Eclipse. So this is the Eclipse. I don't have projects here yet, but I will press the right button. Okay, so when I don't have projects, it doesn't work pressing the right button, but you see how this is done in the future. So here I will simply press import, and the usual workflow is to press the right button and then select import, but in that case, since we don't have projects, we can simply select import from the menu. Then you select existing Gradle project because you already imported and installed Gradle inside your Eclipse. Then select next once again, and here you browse the folder of your project. So here I am in the introduction folder, and I will select 1_ intro project, which was the folder created from the LibGDX. Then I will select the folder. So when this finish, you can see all your folders are added here, and you have a few folders. So the first one is your project folder, which says intro project, and here you see the data of your Gradle project. We're not going to be using this folder. What we're interested in the most is the core folder, okay? So inside this folder is your class that you generated and your initial file for running the program, okay? And what is interesting here is that in this core folder, you normally add all the classes and the packages for your game. So you basically create your game here in the core, and then in the Android and in the desktop, you simply have one file. So you have the desktop launcher, and in the Android you have the Android launcher, with which you will be able to run your core code inside any platform you like, okay? This is the idea. So we're not going to be working too much in this desktop or Android folder. It is possible that there we simply set the parameters of the window that is going to be displayed, but all the game files are going to be carried in the core project inside the src folder, Okay, also here we're going to add all the pictures which are lately going to be implemented as well in the desktop and in the Android folders. And pretty much that's it. So if I run, so for example, this file cannot be run. If I select here run as, you don't get the run as Java program field. And this is because it's not a runnable file. But if I go to the project's desktop, and then I go to the desktop launcher, and then I select run as, I get as Java application. And if I run this file, you get a predefined project from the LibGDX, which is simply a picture of the LibGDX logo. And this is it. Sprite and SpriteBatch. Hello everyone, in the second introductory video of this course, and today we're going to be talking about two of the most important concepts in LibGDX, the Sprite and the SpriteBatch. And this lecture is actually going to be nothing overcomplicated. We're just going to see how a picture is getting displayed on our screen and what is the logic behind it, because this is quite different from what you're used to in Java. So here we are in our libgdx import project file, which is here, and we created it in the last section. So I'm going to remove these two things here. So this SpriteBatch and texture img are predefined, and this is the way that we are displaying actually the picture of the bet logic, so their logo, inside our window. So I remove this because we would like to do everything from scratch. I remove this, and I also remove that one as well, and also the dispose function. That's it. Control S for saving, and you can see that now if I try to display anything, we're simply getting a red screen. And actually I will make the color of this screen different by selecting here 1 and 1. Okay, so now the color should be different. So when you select the color code to be only once, then it is white. So we'll keep it white for now, and I will create three things here. The first one will be the orthographic camera. So hover over here and then import the orthographic camera. So everything that you import is located here, as you can see. Then write Sprite batch, and then write batch, and also hover the mouse over here. Oh, sorry, batch. That's it. So this is already imported, as you can see. And finally write Sprite, and then Sprite, and then import. So as you probably know already from the introductory of the Java videos, now what we are doing is we have predefined classes Orthographic Camera, SpriteBatch, and Sprite, and we're creating instances of that classes. So we're creating here objects. Okay, and what these objects are doing and why we use these classes. So the orthographic camera help us to see something on the screen. Okay, so the orthographic camera is showing us something. The SpriteBatch is going to draw something on the screen, so we're going to use it in order to draw some object, and the sprite is the actual object. So what we're basically doing is that we're taking this object, we're drawing it with the batch on our screen, and finally we display it using the camera. So after we set it up, these objects, now we need to write inside our create method, because we want to create them, right? So the first thing that we will set up is the camera, and let's write camera equals new orthographic camera, and the orthographic camera takes height and width of which we are going to display something. Okay, so if we would like to display the whole window inside our camera, this means that we need to pass here the width and the height of our window. So for example, the height and the width of the window are usually defined in the main file, so they are going to be different for Android and desktop, and for that reason in the desktop launcher we usually define the height and the width of the window. If we don't define it, don't worry, the window usually have predefined values, but for this test I'm actually going to define it, and you will see how this actually works. So let's write here. So this is our config file or config object, so this is how the application is set it, and let's write config dot title equals introduction, then config dot use G20. You don't need to know this, so use G20 equals false, and then config dot width equals 700, and config dot height will be equal to 400. Okay, and we don't have errors here, so this is basically how we set the width, the height of the window, and the header of the window. Okay, let's create our camera, and then we'll run the file. So we have our camera set it up. So as I said, our width and height of the window are 700 and 400, and we would like to pass this to the orthographic camera in order to display the full window. And this can be done by typing gdx.graphics dot get width and then brackets, comma gdx dot get height, sorry, gdx dot graphics dot get height, and that's it. So this is how from the graphics, so from our window, we got the width and we got the height. So we passed 700 and 400. That's it. And then once we set it where our orthographic camera is going to have a look, then we would like to set the batch and the sprite. So setting the sprite batch is quite easy. You simply need to write sprite equals new sprite batch, and that's it. Sorry, here is batch, of course. So this is how you set your batch. So you're setting how you're gonna draw your object, and then you need to set the sprite. So as I said, the sprite is the object that you're displaying, and since we are displaying a picture, then it makes sense that we refer that picture once we create it. So we need to refer the location of the picture, and since we don't have pictures yet here, we have only the bad logic one, which I'm gonna delete because I want to display another picture here, and I will actually put that picture inside the sources folder. So I would like to display this aircraft here, okay? And in order to do this, in the assets here, I will create a package, so new package, and the name will be data, okay? So now we have here the package data, and inside this package I will simply place all the pictures, and you can also place music files, basically everything you need in your project. Press OK here. And now you can see that in this file data I have this picture, okay? And how we are going to refer to it. I will show you how. So write sprite equals new sprite, and then inside write new texture. So texture is another class, predefined class, with which you're basically adding graphics into your game or application. So here let's write texture, and then simply you need to refer the file of your texture, and the file in our case is data/png.aaa.com minus 2402.764.png. Well, maybe I will change the name of that picture once I upload it, because I would like something more simple for you. But yeah, here simply press the location, select the location and the name of the picture, and then we need one more bracket here. That's it. So this is how you're adding a texture inside your project. And let's sum up what we did in the create method. So what we did here is that we referred object to our sprite. So now the sprite knows to what object is referred. Then we set it up the batch, which is going to be responsible for drawing our sprite, and finally we set the camera to have a look at the whole window, okay? And this is very important. Then let's move on. So in this render method, let's say to our system what the batch actually is going to project to. So I write one line here, and it's always the same for every project, so don't worry too much about its meaning. So let's write batch dot set projection matrix, and then camera dot combined. Okay, that's it. And this is the way that you are setting up your projection matrix. It's always the same, so we don't need to go too much in depth about this. Okay, and there's one last thing. So here, when we want to start drawing our sprite, first we need to begin the batch. Okay, so as I said, the batch is what we're going to be drawing our object. So we need to start a batch in order to draw any objects. So first here inside your render method, write batch dot begin. So now you begin your batch, and now the program knows that something will be drawn, and inside write sprite dot draw, and here write batch. That's it. And since we are having only one picture that we want to draw, then we would need to also end our batch. So simply write batch dot end, and that's it. This is how you end your batch. Okay, let's run now our project and see how the picture is going to be displayed. Let's press OK here, and you can see that we're having our plane. The window is obviously resized, but there is one thing to notice here. Our plane is displayed on some random location, and it's not exactly centered in the window, right? So this means that we will need to set the size of this window. So the thing is, in our window, in order to be able to resize it, we first need to know its dimensions. So the window has obviously its coordinate system. So in LibGDX, the coordinate system is a little bit different. So in the middle of the window where my cursor is usually the coordinate 0, 0. And as we are going to the right side, we are getting the positive x direction. As we go up, we are getting the positive y direction, and you should know that. So here in the middle is the 0, up positive y direction, right positive x direction. That's it. This is all we need to know in order to be able to position things on our screen. So this means if we would like to display our plane in the middle, then we would need to drag the plane here down, so in this corner. So this means if our window is 700 on 400, so the width here is 700, which means we have plus 350 in the right direction and minus 350 in the left direction. Okay, and then actually let's draw this here. So as I said, we have a positive and negative direction of our window. Imagine that this is our window, and here, so in that end point we get minus 350 on 0. Okay, then here is 350 on 0. So then up, as the width is 400, here will be 0 on 200, and down will be 0 on minus 200. Okay, so if I would like to display my picture here, then I would set the locations 350, okay, on minus 200, so it's displayed in this corner. Let's try this. So let's write here sprite. So this is when we create sprite equals, or actually sprite dot set position, and then the position of the sprite will be, as we said, minus 350 on 200. Okay, so this is how we're going to position it. And I notice here in the Excel I did a slight mistake. So here is actually plus 350. Okay, so this plus here, and here is a minus. Okay, in that direction is minus. That's it. So now we positioned our picture. Let's see how it's going to get displayed. So run as Java application, select OK. And we cannot see our picture because here it should be minus 200, not plus 200, according our graph. So minus 350 on minus 200. Let's fix this and let's run the picture once again and see what's gonna happen. So now you can see that the full picture is displayed in our window, and now the corner of the picture starts from the end of the screen, which is fine and exactly what we wanted. And this is how you're positioning objects and basically displaying them. So just to sum up, once you have your sprite here, this is your object, and you can do variety of things with it. You can actually do another action that I will just show you to be certain. You can even resize it. So if I write, let's say, sprite dot set size, and I write 100 on 20, then I resize the picture to 100 to 20. And let's see how it's going to be displayed now. And as you can see, our plane now is very small, but it's located in the same location. Okay, and that was everything for today, guys. I hope that you enjoyed that video and you learned a lot. This is the basic concept of LibGDX to create a camera, to create a sprite batch to draw object, and to create sprite for your object. In our games, we are going to use many sprites, so we're going to have a variety of objects and even more than one sprite batch option. LibGDX Orthographic Camera. Hi everyone, as we already created this kind of a dummy project where I showed you how you can basically display objects on your screen and how you can pretty much position it and resize it, and basically what was SpriteBatch, batch, and orthographic camera, I want to take a closer look at the orthographic camera itself. It actually doesn't matter what your window size is, okay, if your orthographic camera cannot display the full window. And in our case, obviously, we set it, the orthographic camera, to display the width and the height of our window, so we're displaying the full window. But imagine in some games you maybe have a map and you don't want to display the full map. You would like to display your map once your character is going along with the game. Well, we are not going to create here a hero and a character and a map and stuff like that, but I just wanted to show you how your orthographic camera is looking at your game. So let's set up different values for the orthographic camera and see how our picture position and size is going to change. Also, I must mention that the orthographic camera is normally used for 2D applications, so it is basically showing a piece of the window that you desire in 2D mode. So let's now delete what we passed to the orthographic camera. Okay, and the first thing I will do is simply to set the size of the window, so we see absolutely the same thing as we did before. So we pass here 700 and 400, and then I would like to remove this set size method so we get the full size of the picture. Okay, let's run our game and see what happens. So now you can see that there is no difference because we pass the same values as the window has. But what if we change these values in the orthographic camera? Do you think that the size of our window will change, or there is something else? Let's have a look. So let's change these values to 1000 on 800. And normally what I would expect, and I guess you would expect the same, is that the picture is going to resize and look smaller. So you can see the same here. Now our plane looks smaller. The size of the window is the same, 800 on 700, but the camera is showing our object from further distance. And for that reason, we can see it smaller. And on the other side, if I reduce here the size, let's say if I make it 500 on 200, then if I run the application again, the camera should get closer to our object. And you can see here that the camera actually gets closer. So this is basically the idea of the camera, is to have a viewpoint regardless what is the size of your window. So you don't stick into the situation when you need to resize your picture in order to display it in your game. So yes, basically that was everything I want to share with you for today for the orthographic camera. It's quite important, and actually if you want you can play further with the camera and basically with the other objects and code that I wrote in this game if you want to get better and to really understand it. deltaTime. Hi everyone, today I want to talk to you for a very important concept in LibGDX and actually in the game's development in general, and this is the delta time. So it is very important in your game to have the delta time set it up, and I will tell you why. So imagine you have your game, a device that runs games with 30 frames per second, and on the other side you also want to run your game in a device that is running with 50 frames per second. So normally, if your object is moving, let's say with 1 meter per frame, then depending on the different device, your object will be moving with 30 meters for 1 second, okay, or on the other device it will move with 60 frames for 1 second, okay, because they have different frames per second. So pretty much the aim here is to make the distance that our object is passing independent of the frames but dependent on the seconds, and for that reason we can use delta time. And this is usually something that you don't need to care too much when you're creating your games, and it is usually predefined as a back process, but I want you to understand and get some idea of how the games actually work and how they can be run in different platforms regardless the frames per second that they are played. So let's do a simple experiment with the delta time. I already added private float here called delta time, and the delta time will be equal to 0 at the start. So in our render method, let's write delta time equals gdx.graphics.get delta time. Okay, so this is how we set this variable to be the delta time, and then I would like to display it. So let's write system.out.println and then delta time inside the brackets. Oops, sorry. Delta time. Okay, that's it. And here we're going to print the delta time. So let's run our project and let's see what is going to happen actually. And have a look here at the command line. So as you can see here, we're rendering usually, so my computer, I know that it renders normally the game with about 60 frames per second. So for that reason, every frame you see 0.016 seconds, which 0.016 is basically equal to 16 to 60 frames per second. Okay, but as you can see, this time is not always the same. Sometimes you get 0.017, sometimes you get 0.014, and so on. It is definitely not always the same. Even sometimes you are getting more frames or less frames. It depends. So this means if we have different frames and our object is dependent on the frames, this means that our object will be very laggy, because imagine sometimes it will move with 30 meters per second or with 30 frames per second, and in some other cases with 60, which is a double speed. Okay, so it will move forward faster and slower, and this will create some lag inside our game. So this is why we need the delta time. The delta time is the time between the current frame and the last frame of the game, and as you can see, this is the reason why this time is changing. So basically, when you use delta time, depending on the every frame, so if you have different numbers of frame, then the delta time is also going to be different. So if the delta time is different, then at this particular frame your object will change the time relative to the frames, but it will not change its speed. Okay, and I can prove you this. So let's create another variable here, private float distance equals 0, and then here down I write distance equals distance plus 2 multiplied by delta time. Okay, so here we're incrementing the distance depending on the delta time. So here we're incrementing the distance with 2 times the delta time, and I will actually place this statement below, and here I want to display the distance. So let's run the code now and just analyze what we're seeing from the delta time. So I will run it here, I will leave it for a little bit, and then I will stop it. So what you can see here is the distance basically, and you can see that the difference between the distances is not pretty much dependent on the frames at all actually. So you can see that here we have 3.97, then we have 4, then 4.3, then 4.7, so it's increasing with 0.03 the distance. And this means that using deltaTime, we're increasing the distance of our object regardless on how many frames per second we're running our game. And this is very important. And I will make this number even more significant, so let's make it 20, and you see now the difference even more clear. Okay, here we go. So here we get 43.7, then 44, then 44.4, and you can see that the difference between these numbers is about 3.5 at any case. So this means our potential character will move with the same speed in every frame. So that was it, guys, for the deltaTime. You will not need this concept in order to create your games directly. This is usually happening behind the scenes, but I just want to explain you this so you understand better how your games are developed and how they work inside any device. Game Lifecycle. Hello everyone, today we're going to talk about the life cycle of a game. And this is important concept to know before you jump in creating your own games. So here, as you can see, I have no additional data, and on the other side I have all the methods that are working with the game. We have create, render, dispose, resize, which is when we resize our window, pause when we want to stop our game for a second but do not kill the application, and then resume the game, which is actually connected to the pause function. We also have the ones that you probably already know, the create. This is when we create our game, so here we initialize the game, then render, and usually the rendering is happening 60 times per 1 second, which means 60 frames per second for most of the devices, or sometimes 30 frames per second as well. Then the dispose, which means that if you would like to kill an object to remove it from the game, we're going to dispose it here. And I want you to see how these methods actually work, so we're going to do today a simple test. Let's write in the create method system.out.println, and here I write the name of the method, create. Okay, so we will check when the create method is done, and then we're going to do the same for the rest of the method. So here I write render, then dispose, here I write resize, then pause, and finally resume. Okay, that's it, we're ready here. And now I will run our program so you will be able to see when we're calling each of these methods. So here we created our window, and you can see render method is happening all the time. I will resize it. Okay. And then I will close it. That's it. So let's now analyze the data that we received. So let's actually go from the beginning. Okay. So firstly, when we create our method, we immediately get the create, so we create our application, so the create method gets called. And immediately after that, as the system needs to set the size of our window, we're calling the resize method. Then as you can see, we get plenty of render methods because every second we're rendering our game, as I said, about 60 times. And you can see here, if you search, you're getting called the resize method, and this is because, if you remember, I resized the window while it was opened. So once I do this, immediately the resize method is called and it starts working in the background. Okay, so once you close the game, you can see that you get this method. So you get the pause method and the dispose method. So first the application gets paused, and immediately after that disposed. And this is very important to notice here, because if you create variety of objects in your game, it is very important to add them in the dispose method, so you're sure that after you close your game, all of your objects are actually really killed and there is no processes working on the background. That's why it's important always to add your objects in the dispose method as well. And you would ask me, why do we need these methods here? Well, and how we actually get them. So we're normally getting them from the application adapter. So this sentence here intro project extends action adapter means that our file is implementing all the methods from the action adapter. And actually, if I press Ctrl and then select it, you can see that in the action adapter we're getting all of these methods actually. Okay, so this is the way that it works. So the application adapter has these methods predefined, and then we can use them here and actually override them, which means we can add new functionality inside these methods. So that was everything for the game structure, guys. I hope you understand it correctly, and this is actually quite different from the way we're creating games in Java, because LibGDX libraries has their special features. Input processing. Hello everyone. Since you learned the most important features of LibGDX, today I want to show you and to do some tests on how you can process user inputs inside your game. So we will learn how to press keys, press the mouse, and also scroll on our screen. Okay, so let's start. The first thing you need to do is simply to extend our intro project class also with the input adapter. So since we have all our methods here, I write here implement application listener, and I will import the application listener. Okay, and also this will extend input adapter. Okay, I think the extends input adapter should be first, so I will do it. Here we go, and you simply need to import the input adapter package here. Okay, we're ready. So we're now error-free, and what we can do now is to overwrite the input adapter methods inside, and then overwrite implement methods, and you will be prompted to this window here, and the methods that we will be using are key down, scroll, and touch down. Okay, these are the methods. As you can see, there are also other methods like key up and key typed, but these are the methods that we're going to be using. So select here key down, scroll, and touch down, and when you press OK, you will get all these methods added in here. Okay, so we got our methods, and let's delete this in order to have more clear ID. So here we will return true, and the same I will do for the next ones. So now we would like to do a simple test in order to check if these functions are working and the system is really taking the user inputs. So let's write here switch key code. So let's write here the first case, so case key and then space. So if we press space, sorry, here is keys, and then this means if we pressed space, then we would like to print space on the screen. So system dot out dot println space, that's it, and then write break, and we're ready here with this line. Then let's write another case, so case keys dot p. So if we press the P button, then system dot out dot println, and I would like to display in the console P. That's it, and this is our check for whether we pressed space or P keys. That's it. Okay, we're ready here. And then let's close that switch statement, and we'll return true. Then in the next method, in the touchdown, here you can see we're passing the screen X location, screen Y location of the touch, pointer and button. Well, pointer is a little bit more advanced concept, and this is usually when the user presses the screen with more than one finger. You know, some phones have the option to press the screen with more than one finger, and in that case the system is creating two pointers, one for one of the fingers and the other one for the other finger. But in that case, since we're still beginners and this is the introduction, I am going to create no pointers, and simply we're going to check the X and the Y location on where we touch on the screen. So let's write system.out.println, and here inside I write click plus screen X plus comma plus screen Y. Okay, that's it. And let's close this. So we're ready here because we want to print the location on where we pressed. And finally, let's update the scroll method. So here I will again write system.out.println, and in the brackets let's write scrolled plus the, so here I will do scrolled X, actually like this. So scrolled X plus amount X plus scrolled Y plus amount Y, and that's it. This is how we're going to display how we scrolled on our screen. Let's write a semicolon here. And finally, in order to run everything, let's write in our create method, let's write here GDX dot input dot set input processor, and here in the brackets write this. Okay, so this is how our window is taking our inputs, and I saw some error here, so let's see what it is. Okay, let's import also the keys library in order to understand the keys, and we're ready to run the program. So I will run as Java application, press OK here. Okay, now extend a little bit this window so you can see. So this is the window, and if I click on it, you're getting the X and the Y location of my click. Okay, if I press space, so now we press space, you get space, and if I press P, you get P, space P, space P, space P. That's it. And also if I start scrolling, see now what is going to happen. So now I'm scrolling my mouse, and you can see that is giving me the X and the Y locations of the mouse. Okay, so if I place the mouse here and I start scrolling, I'm getting -1 and 0, and this is depending on which area of the screen I am. Okay, so pretty much that's it, guys. Thanks for watching. This is the way you are setting your inputs in Java. Actually, this is the preferred way. There are other ways as well, but this is the most easy one, using these functions, and also extending the project with input adapter. And this is actually quite simple and easy to grasp. Hi everyone, welcome back to the course. In this section I'm going to talk about some very simple concepts about LibGDX, so you're able to understand it way better. The first thing you will need to have set up is your folder with the projects. So I already created a folder called projects, and here inside that folder I will place all our projects that we're going to develop throughout the course. So as you can see, guys, I already created a folder called project, and here I will simply press the GDX setup creator, and once we are inside it, we're going to create a project called hello world. Then the package is going to be called com.martiny. The class will be with the same name called hello world, and then you need to search a folder where you want to install all of your projects. I always prefer to install all of my projects inside a single folder. So the folder will be called projects here. And you just need to find that folder. So here is how you can do it. Start searching in your folders. Then my folder is in course, libgdx, and then projects. Okay. And very important thing, finally, until you create the game, inside the folder projects, create another folder with the name of your new project, because if you don't do it, you will not have separate folder for each project, but simply the files of that project inside your main folder. So let's call our folder hello world, or actually _hello world. Okay, so we are going to place this folder at the first place of our project section. Then select the desktop, and from the other fields just select box 2D. That's it. Let's now generate our projects, and I will see you back once the project is completed. Okay, our project has been created, and these are the messages that LibGDX give us. So I see done, and that's it. And now here simply press import, then existing Gradle project. Here press next, then next again. And here we're going to search in the folder _hello world. Press finish here. And now, as you can see, we have imported our projects. So here you can see the hello world folder, and then here you also have the hello world core where our main files are placed, and then you have the hello world desktop from where you will run the application for desktop by simply pressing the desktop launcher. So let's see what we have until now. Let's launch our program and see what is the initial state of it. As you can see, as actually we did in our installation, you are getting the BetLogic logo and some window as well. But now I want to change that a little bit so you can understand how basically LibGDX works. So let's simply go to the Hello World core and then select the folder src where our files are, and here you have the Hello World class. And what is predefined here, I will make it a little bit bigger so you can see it. What is predefined here is that we have our class Hello World, which extends the action adapter. Okay, and there are two main things that are happening inside this class. The first thing is you create the SpriteBatch, which is a component, or actually we have the batch object, which is object of the SpriteBatch class. And with the batch object, we're basically drawing and controlling the workflow of our game. And you can see here, when you write batch dot begin, our game begins. Then when you write batch dot draw, we're drawing something in our game. And this is basically the main use of the SpriteBatch. And also what we're doing here is that we're saying that the batch equals new SpriteBatch, which means that now we're able to use the batch inside of all other classes. You normally need to create one SpriteBatch inside your first class, and once you do it, you can use it in all other classes. You will not need to create other SpriteBatches because the program could get confused and your game to be prevented from working properly. So this is about the SpriteBatch. Then you have the texture. Well, if you can understand, the texture basically says that you're importing some images or objects inside the game. And this is what we're doing here. In the most simple application, the texture is having an object image, and with this image we're adding the BetLogic logo inside our program. But actually we will change that. So I know that in most of our programming languages you're creating some functionality to say to the computer the sentence hello world, but in our case we're simply going to display our world using this picture here. So the picture is actually uploaded inside this section, so you can simply download it, and here I will place it in our game. So I will simply take it and drag it to the assets folder. So inside the assets are all the images that we're using inside our games. So simply drag it here, press OK to copy it, and that's it. You can also see that the BetLogic image is actually here, and this is how we displayed it. So instead of it, I would like to display the world image. So let's delete this BetLogic image from here. That's it. And now if I run the program, I will get an error because the BetLogic file is selected here, but we don't have it in the assets folder. So instead of BetLogic, I will press here Ctrl F2. I will press here F2 so I can actually copy the name of world.png, and I will simply paste it here so the program knows what file to use. Okay, that's it. And as you can see, the way that we are adding the image inside our folder is through this batch.draw image, and here are the X and the Y locations of the image, and I will show you how this basically works. The first thing, before running the game, we would like our hello world to extend game, the class game, okay? And this is done because we would like to create a game, okay? We don't want only to listen the action, but we want to use the game class, which has more methods that are usually used inside games when we use libgdx. So simply here import game, and now the game is imported, and you can see that the application adapter now has this yellow underlining, and this is because we are no longer using it in our code. And let's run our code now and see what is going to happen. So again, we go to the hello world desktop and simply press desktop launcher, then run as Java application. Press OK here, and you can see now that our PNG image is displayed on the screen, okay? But let's say that you would like to move the image, or you would like to resize the window so it incorporates only the image and we don't see the rest of the screen that we are not using. And I will show you how you can basically do this. So as I told you, here are the locations of our image, and we can simply change them. So if I put here 1000 and I also put 1000 here, then the location of the image will be drawn from 1000 to 1000. Let's run the code now and see what is going to happen. Well, you can see that image is not here because I probably moved it too far. So let's do 100 on 100. And let's press OK here. And now you can see that the image is moved to another location. So we can say that here is basically 100 on 100. So this is the initial point, and then we display all the image, right? So this is how you can move image on the window. But how you can resize the window? Well, it is actually not that hard. Let's open now the desktop launcher, and here you can define where and actually what is going to be the size of your window. It is very simple. You simply need to write config. So as you can see, config here is the object of the application configuration, right? So changing the config, you're basically changing some components of the window. So if I write config dot width equals to 500, and then if I write config dot height equals 500, this means I will resize the window, and the window will have width of 500 and height of 500 as well. Let's run the code and you'll see how it is resized. And here you can see our window now has been resized, and we have more highlight on the picture, so we don't show too many pixels with no data displayed inside them. And I always advise my students to play with all available parameters in the program. So here you can see that there are different parameters. Now you can change these parameters here to see how the image is going to move, and this is basically how you can modify your picture, display your picture, and resize your screen. So since you know all of these methods to operate on your game, now you are able to move on to more complex toolkits and classes that you can use inside the game. But for this we're going to talk about in the next video, because this one is going to be too long anyways. So guys, really thank you very much for watching, and I will see you in the next video. Creating libgdx game project. Hi everyone, Welcome to this section where you will create your first, more complex LibGDX game, which is called Money Hole. But about this I will show you just now when we go in the IDE. As you can see, I already have the game here, which is called Money Hole, as I said, and I will run it and show you what the game is actually all about. Let's run it as Java application. So once you run the game, you will basically see this screen with these doors. Actually, it looks quite nice, and the idea is to select some of the doors. So when you select some of the doors, and if another door is opening, and after that you see where one of the monsters is, then you can either change your choice and select another door, or you can select the same one. And as a matter of fact, you should always change your choice if you want to have higher percentage to win the game, but about this later. However, the idea of the game is, as I said, you have two monsters and you have one prize. So the idea is to get the prize, and the prize is a car. So if I check now this one, I got two monsters, so I lose the game and I get the message you lose. In another situation, maybe you select the prize, so here you've got your car and the car is displayed, so you won the game. This is basically it. And to create this game, we need to create several classes and build a comprehensive LibGDX project. But how we are going to do this? So here is, guys, all the classes that you need to have. And you can see here that first you have your core project, which I will show you how they are built in the IDE. So you have your core folder, and then you have your desktop folder, right? So in the core folder, you have a few classes. You have the door class, which is going to be located in the game object package. But let's actually first talk about the packages. So you have the game object packages, you have the manager package, and you have the running class package, which you usually have for every LibGDX game. So the first what we're going to do is to create the game objects package, and inside you will create the door. Then we'll move on to modifying the running class. After that, we're going to actually create the main class, or maybe actually we'll create first the main class because it's the easiest one. So after we complete the whole three classes, we will build the game manager, and this will be your first test of the game, which is not going to be completed. And after that, we'll add some game logic using the input manager, and finally the text manager to display the text inside the game. Despite the classes, you need to know how the game is basically working. So we first have the initialization, which is basically the closed doors and the background and the initial text that you need to select the door. So this is our initialization part, and for this we have initialization function. After you pass the initialization and you perform some action, the system is taking input, then the initial state is updated, and then we render objects, which means that we change the way the objects are displayed depending on the input that we done. And after the objects are changed, then we go back to the take input stage, and again the system is going to take input, and then we'll again render depending on the inputs. And after we have result of whether you won or you lost the game, then the end section will be also updated and we'll reach it. And from there, actually I had to draw another arrow here. From the end section, we can actually go back to initialization section because you can restart the game, and we will add for this the restart function.